All right, today we're going to talk about the chain rule. I think the easiest way to get started with this is by doing a couple of examples first. Let's say we have a function. Let's call it f of x. Good old Frank here. So f of x is equal to, let's see, x squared plus 1. Put it in parentheses. We'll raise the whole thing to the fifth power. Now, if we wanted to find the derivative of this, we could expand this, but if you've done it once, it's kind of fun, kind of interesting, but after a while it gets pretty tedious. But we have a rule that we can find the derivative of f of x without having to do that. First of all, notice there's an inside function. That's inside this fifth power function. Okay, in order to do this derivative, we're going to take the derivative of the inside function. Excuse me. And you can easily see that. Let's see, that's 2x, and the derivative of a constant is 0, so that's just 2x. Okay, let's take the derivative of the outside function. This is a little different. Now notice this inside function, we can give it another name, derivative of outside function. So the target of this fifth power is not x, but let's put a 5 out here like we would in front of x. We'll open the parens here for a minute, and then subtract 1 from our exponent. So we applied our power rule, but what we applied it to was against x squared plus 1. So once we've done all of that, the derivative of f of x, the whole function, is equal to the derivative of our inside function times the derivative of the outside function. Okay, we can clean that up a little bit. At least multiply the outside, 10x. Well, we didn't expand the function at the beginning, so we're not going to expand it now. So there we go. That's our answer. Let's try another example. Very similar. Okay, let me scroll down just a little bit here. Okay, get a little bit of room. Here we go. Let's take another function. Let's f of x is equal to x cubed plus 2x, that in parentheses. Let's use a different power. Hey, let's use the sixth power. Still pretty tedious to expand that, so let's not do that. Well, again, we can see there's an inner function, and there's an outer function. Notice when I draw these circles, one circle's inside the other. It's a pretty good indication that one function's inside the other. Okay? Inner function. Oh, that's the derivative. Okay, the inner function's this x cubed plus 2x, so we want the derivative. And that looks like what? 3x squared plus 2, so we're just using our basic rules. Okay, we'll put that in parens. And then the outer function, derivative, okay, Well, we put our exponent on the outside. It's going to be, we're taking the derivative, okay, so we're going to subtract 1 from 6 and get 5. And we get taking the derivative of this, so we'll write our inside function inside here. X cubed plus 2x. Now once we figured out the derivatives, the derivative of the big function is 3x squared plus 2 times 6 times x cubed plus 2x to the 5th. We can clean it up a little bit. We can multiply that 6 in here. We get 18x squared plus 12, our parens around it, times x cubed plus 2x to the 5th. Now notice, here's our inside function. Our inside function still remains in the final derivative. But the power right here is 1 less than the power up here. We also have its derivative here in front. Well, it's multiplied by the 6 we got from the derivative of the outer function. Okay, that's a couple examples. In the next video, I'll show you the actual rule.